90% of the world's goods are being transported by the sea. This means that port and harbor cities plays a very huge role in supplying and delivering goods in each country. At this moment, some of the traditional ports are slow while others being even slower when it comes to processing the import and the export of the goods. This can cause the arrival time of the goods in their destination to be way long. But what if I tell you the entire operation can be way more efficient? Hence, the idea of smart port born. So, what is smart port anyways? Smart port is an upgraded port that uses automation and innovative technologies such as big data, artificial intelligence, Internet of Things, and blockchain to improve its overall performance. But is it really benefit? It actually does. AI analyzes all the ship routes and optimizes the most efficient course, which potentially reduces the chances of having any ship needing to come to a total halt for another ship to move, leading to time wastage. Blockchain technology could possibly create an open platform that is not bogged down with paperwork. IoT connectivity would enable real-time tracking and monitor cargo, where data insights will allow valuable data-driven decisions to make ports smart. But despite having all these technologies for the past few years, why there wasn't a single smart port was built anywhere? Simple. It is because they needed something for communication. Something that has an ultra low latency and an extremely fast internet speed, so that any actions can be done in real time, as well as download any large files in few seconds. And that's where B5G comes in. Similar to 3.5G and 4.5G in the past, B5G or Beyond 5G is the improvement done to 5G network before introducing 6G network. B5G could possibly work at even higher frequency bands such as terahertz band ranging from 0.1 terahertz to 10 terahertz. This would allow more devices to be connected to B5G network with a crazy high speed of internet. Next, the latency can be pushed even down than what it is in the 5G network. One of the biggest upgrades for B5G and 6G over 5G network would be integrating satellites with signal towers to achieve seamless global coverage and interconnection. Next, Navin will be explaining on the challenges and the solutions of B5G network.
Thank you, Jay, and hello everyone. Now, about the challenges, I've uncovered 3 challenges for 5G in smart ports, with the first one being the frequency bands or the wave spectrum. The ability to give users of the devices capable of higher data rates, the requisite bandwidth presents a challenge. Networks can accomplish this by using a frequency greater than 6 GHz. Unfortunately, it's the range that is a problem. 5G and beyond 5G technology uses higher frequencies, or higher frequencies are meant higher speeds. It also meant shorter range. Hence, this is why we have the challenge of having smaller millimeter wave signals travel across longer range, and obstruction in between the signal originating from a cell tower and an end user poses a very big challenge. The second problem is, of course, the ultra low latency services. Now, to maintain a smooth operation, mission critical apps and self-driving automobiles need extremely low latency services. In mission critical applications, any delay could have unforeseen and disastrous effects. To meet the requirements of medical applications like remote surgery, a latency of less than 1 millisecond must be achieved. And of course, the third problem is obviously security and privacy. One of the most crucial components of any wireless transmission system is security. For end users, the network must guarantee security and privacy. Plus, it is a difficult task to achieve because of the variety of technologies and the number of devices connected to the network. To securely communicate between devices and cloud application servers. So what about its solutions? Now, for frequency band or the wave spectrum problem, 5G needs significant new harmonized spectrum, so clearing prime bands should be prioritized to meet market demand. So number one, regulators should aim to award 100 megabytes of continuous mid-band spectrum per operator for 5G launch. And the second solution is to increase a low band spectrum capacity by assigning all available bands including 600 MHz. Now, in terms of the solution for an ultra-low latency service, the mobile network architecture for 5G network is to offer low latency, obviously, so significant improvements must be made to the core network itself and the radio access network. Now, for the core network changes, we could be moving the material closer to the end user and shortening the journey between devices for crucial applications are key features of the revised core network, signaling and distributed servers. An example of this is, of course, video-on-demand streaming services. The second change in achieving ultra-low latency service is, of course, making change to the radio access networks, or RAN. The RAN will need to be reconfigured in a way that is very flexible and software adjustable, that it could handle the very various characteristics in order to achieve low latency. There also has to be new development for new radio techniques, and these approaches must also increase resilience and coding in order to attain these high levels of reliability. Now, onto our third challenge, which is security and privacy. Solution for this is that 5G architecture should have service-oriented, privacy-preserving, and privacy by design methods. Take, for example, location data. Location-based privacy demands anonymity-based methods and platforms that allow users to conceal their identities, maybe even using a pseudonym. Before sending a message to a provider of location-based services, it should also be encrypted. Location privacy can also be protected through obfuscation techniques, which degrade the accuracy of location data. That is all from my part. Thank you.
Hi everyone, I'll be explaining on how 5G and B5G operate. As mentioned, 5G is used at ports and harbors because of high capabilities. Since 5G was only introduced in March 2021, ports and harbors has been using 4G for many years. Since 2008, only 4G was introduced. There are three key characteristics that makes 5G superior: bandwidth, capacity, and latency. 5G's bandwidth is higher than 4G by 5 times. But what is bandwidth? Bandwidth is a volume of data that can be transmitted over a network. So, you can imagine a bandwidth as a box which carries data, and 4G is just a regular screw box, while 5G is a shipping container. Latency is the time for signals to travel from one device to another. The lower the latency, the better. Here's a little fun fact. It takes about 10 milliseconds for lights to register in the human eye to reach the brain. And that is the latency for 5G, while 4G's latency is at 50 milliseconds. Meanwhile, 5G has a higher device capacity than 4G. The difference in capacity are that 5G can support up to 1 million devices versus 4G, which can support up to 4,000 devices over a square kilometer. Therefore, if 5G is used at high device locations such as stadiums or harbors and ports with thousands of sensors and remote devices, there will be less traffic disruption in the network. Next part of the video is implementations of B5G to smart ports.
And now we know about how it operates, let's go into more detail. Now we split smart port into 3 different parts, which are smart infrastructure, smart traffic flow, and smart logistics. In smart port, smart infrastructure is to increase productivity and utilizations of digital technology, which is also essential for automatic port operation. Second, it is to maintain the high volume of data that we need a smart traffic flow to avoid any congestion. It is essential to ensure that seamless and efficient flow for the assets such as automated guided vehicles, trucks or driverless trucks, remote control aqua drones with the sensors, video camera, geographic information system, and intelligent transportation system. The aqua drone can be used for filming, the underwater, which is to inspect ships or piers, fault finding, and doing jobs that puts normal employees in danger. In this case, smart port require high reliability and scalability network, and in order to do so, we require an end-to-end power consumption model for a B5G network architecture which integrated massive MIMO, indoor millimeter wave, and Li-Fi Atto cell technology to fulfill the requirement of ultra-dense networks. In addition, collision prevention algorithm like Quad 3 can detect anomalies when 2 vehicles or vessels are on collision cost and send alert to the operators. Other algorithms can detect the sudden decreasing in speed of the vessels or changing directions to alert port operators for potential hijacking or piracy. Smart logistics supports the automatic movement and handling of containers through unnamed cranes and equipments while facilitating communications among port stakeholders. In addition, it includes the efforts to sustain the port environment protection. Lastly, Smart Port Access Control, the Free Trade Zone, which is FTZ, is one of the most secure areas in the port. Use two-factor authentication for access control using a combination of access card and biometrics such as fingerprints or facial recognition.
Next, let's look at the implementation process of the Smart Port. So as you can see from the video itself, these are the summary of the implementation process. There are 5 steps. The first step itself will link a smart port strategy to the overall port strategy by acknowledging a smart port which is started internally by the organization before it began developed into an international smart port strategy. And the second step itself is to identify the pain point of the smart port technology that could be fixed, in which each of the organization have to focus on how they can digitalize operation before working outside of themselves. Step 3. List down all the possible solutions based on the issue that you found on the step 2. In step 4, decision making on which type of port to buy, whether it's an off-the-shelf technology or the custom solution. There are certain pros and cons of the shelf technology which is less time consuming because they are the pre-prepared technology for you. And however, for custom solution is that we have to engage with the vendor and deal with a custom solution which causes more time consuming. So in the last step, we manage the risk management by using the agile model. This is because the smart port is connected with many different kinds of system and solution. Hence, this evolution of the smart port is growing rapidly and we need to list down the risk and the potential impact bring to the environment.
Now coming into my part, I'll be sharing with you on the potential applications and functions of smart ports. As presented by Jay and Navin, we now have a clearer idea on the concept of smart port. Even with your information, let me ask you some questions. What makes the concept of smart port unique compared with the traditional or current ports today? How is it seen more desirable from the current ports? Pause the video and try and ponder some answers of your own. Right, I hope that you have got some answers of your own. I'll share with you a hint. It's a very simple concept. And the thing is, the smart port is here to transform port operations to become more efficient and smarter than ever. So without further ado, let's just dive into my part to what my team has to offer. So starting off, smart ports can deliver 3 unique elements. The first is its greatly improved interconnectivity. But of course, the currently used machinery will need to be upgraded to support these capabilities. Second is its support for high bandwidth. And third, the ultra-low latency which enables it for time-based critical operations. These 3 key points make smart ports a class above from the current ports. In an overall perspective, some of its potential functions aim to utilize, for example, having IoT and satellite with beyond 5G technology, which can aid in real-time information gathering, security, for example, the customer's, stakeholder, and employees' safety on site, as well as ship collision avoidance, larger yields with lower resources, and energy efficiency in terms of the port's operations. Going further into the detailed look at some of its potential applications include 3 main categories, which are automation, expanding network efficiency and functionality, as well as extended functionality with IoT, also known as Internet of Things, and data. For automation, smart ports aim to automate key port activities and providing real-time visibility of logistic movements in their supply chain. Automating machines or automated guided vehicles, also known as AGV, include barges, drones, trucks, forklift trucks, ship movement, and even robots. But for robots, it can have the inclusion of AR and VR. One example utility of this is for remote ship maintenance. And lastly, for automation, besides automating machines, the application of connected robotics and autonomous systems, also known as CRAS, will likely be used. This will bring about the benefits that include energy efficiency, lower computing latency, and localization accuracy, which is the same thing as mapping accuracy. Under expanding network efficiency and functionality, it focuses on building a network supporting virtualization via software-defined networking, also known as SDN, which allows different parties on site to use the network securely with their own dedicated channel of bandwidth and latency requirements. Some use cases include remote-controlled ship-to-shore cranes, automated gantry cranes, automated cargo-moving vehicles, predictive maintenance, and drones. This, in a way, helps leverage the benefits brought about by 5G or beyond 5G via segregating the network to avoid congestion and keeping a more efficient and organized network communication system. For the last section, extended functionality with IoT and data, it varies widely according to the use case and intended use of the specific device. So here our team have tried to narrow it down with the following. One is having smart drones for real-time monitoring, real-time ship-to-shore communication, for example, supporting communications to aid in optimizing loading and offloading vessels operations when arrived, for leveraging the traffic management. Another use case is utilizing the data gathering ability of these devices on activities such as container stacking optimization and streamlined crew rostering, such as through the deployed drones cameras. And third, it helps the port monitor cargo and ships currently at sea. Fourth, IoT connected sensors can enable companies to know exactly where goods are at any given moment when cargoes are in transit. And lastly, the real-time management can be brought in to enable remote-controlled gantry and quayside cranes. Alright, so with all the aforementioned potential functions that smart ports can bring, we also need to consider the potential hardware and software needed. When considering the new hardware which will support the 5G and beyond 5G technology, a general guideline is to look at it from three functional categories, being smart infrastructure, traffic flows, and logistics. Some example functions the hardware also need to be able to support include enhanced mobile broadband, also known as eMBB, which enable new data-driven experiences requiring high data rates, such as enabling the use of AR and VR that fundamentally requires that high bandwidth capability. Another thing is ultra-reliable, low-latency communication, also known as URLLC, which is about time-based critical operations for applications that need to be fed with real-time data, as well as massive machine-type communication, also known as MMTC, which focuses on solving issues related to an area with high density of connected devices, such as for situations for handling a hotspot for high concentration of devices in one area. Some of the most needed hardware our team could find were two things. One is supervisory control and data acquisition, also known as SCADA, and programmable logic controller, also known as PLC. For SCADA, it's a system of combined software and hardware that are used to control dispersed assets, and industrial processes, locally or remotely, via centralized data acquisition and supervisory control. In layman terms, its purpose is for monitoring, gathering, and process real-time data while also interacting with devices, mainly sensors, directly. An example use case is it can be used across multiple ports spread apart geographically. PLC, on the other hand, manages the connectedness and network of the smart port interconnected devices, since mainly the usage of 5G incorporates IoT devices, of course. Or, in another way to explain PLC is that it's a solid-state device that performs logic processing to create a computer network in remotely located ports. PLC can also be used as a field device that can act as a remote terminal unit for purposes such as controlling a specific equipment function when wire-based communications are unavailable. So those were about the potential functions and required hardware to support the arrival of smart ports. We can break down the OSI model into 5 layers, which are terminal, physical, service, network, and application layer. The terminal layer is in charge of collecting data from the 5G IoT sensors to be passed onto the physical layer, their 5G CPE wireless terminal. The physical layer is where data are analyzed and processed. This layer is also grouped into 3 slices, namely MMTC, EMBB, and URLLC. Machine learning techniques will then be used at the service layer, and every slice network will be grouped into 3 more slices according to the AAAS, PAAS, and IaaS services. At the network layer, it provides the control and data plane functions and storage services. And lastly, the client-server environment is provided at the application layer.